so here we are at test 3. And we know test 3 is about our factoring life. So everything on the test is going to be about factoring. Solving with factoring, adding, subtracting with factoring, factoring. Okay? So what we're going to do today is I'm going to put some problems up on the board. You're going to work them. The questions or worksheet that you have or the test review that's in your booklet, you should be working on that already. If you haven't started, you might be working on the online one. That's fine too. But at this point, if you haven't started working on any of them, the one in your booklet is probably the better one. It's about as close to your test as you're going to get, minus about 8 or 9 problems. And then of course you have the annotated answer sheet right behind it, so you can look at it. The videos are on YouTube, so you can look at the instructor working those problems. That's why I don't do those, because you have all that stuff there. But the problems I put on the board. See how the multiple choice works to help us, how we can use it, you know, things like that during each problem. Here we are putting some problems on the board. If you don't understand anything, you just let me know. You have multiple choice selections for numbers 1, 3, 4, and 6. Think about what we know. When we look at this stuff, first thing we should be asking ourselves is, can we factor it? And then that first question is always, do they have something in common that we can take out? And we want to make sure we factor out the greatest thing, whatever it is. Number 1 has some multiple choice selections. And looking at the multiple choice selections, can you tell me, if they're asking us to write it in lowest terms, which one of these answers can't be our answer? Undefined? What does undefined mean? A number divided by 0, right? The only way we can get that here is if they ask us to plug something in. Do we see that? The lowest terms means we're going to factor and see if we can cross out some stuff. Undefined means that we have a fraction that has a 0 in our denominator. We can't even get that here. That doesn't even apply in this case. So we have to know what these words mean. And undefined means that you're going to have a fraction with a 0 in the denominator. Doesn't apply here. That can't be my answer. Okay, so now I've ruled out one of the answers. I haven't even done anything yet, but I ruled out one of the answers. Now I know I need to factor whatever I can factor and see what I'm going to get left over. Now this gives me a hint right here that a 6 is going to be there somewhere. Do you see that? Just use it. It's going to give you some hints, okay? So we know for sure that we can factor this thing on the bottom by taking out what? Think we're okay with that? And that leaves us x minus 4. On the top here, look at the problem now. When we look at our binomials and stuff, we're usually looking at a letter, then the number, right? Letter, then the number. But look at how the structure of the problem is. We have letter and a number and a letter. Doesn't that look weird? So if you have something that's not following the aesthetics of the problem, you can do something about it. What can we do about that stuff on the top? We're going to factor out. Always think about taking stuff out now, right? We're going to factor out a -1, and that's going to change our sign so it can make it look like everything else. Because in our hearts, we look like it could cancel, but the signs won't make it work. So we got to make it work mathematically by factoring out a -1, and that's going to change my -x to a +x, my 4 to a -4, and I'm going to write it so it looks like everything else. Now, if you left it as the -1 on the outside, and then -4 plus x, that's fine, but your eye might not think that it's the same as down or below. You see that? So it works in our best interest to go ahead and write it in the right order. Now we see that we can cross this out. Remember that you cannot separate anything that has a plus or minus sign holding it together. Okay? Those things are married together. You can only break up multiplication, that's dating. You can break that up. But if they married, you can't break it up. Don't break up a happy home. So now what's left? We have that -1 on the top and the 6 on the bottom. That makes B our answer. Look for this to happen in a couple of your problems. Give or take about 3 or 4, where you can factor out that -1 to make it work. Number 2, factor completely. Asking yourself the same questions every time. Do they have anything in common that I could take out first? Do they? Nope. Is the first term perfect? No. That 3 says no, it's not perfect, right? So that rules out perfect square trinomial, doesn't it? Okay, so we're going regular with it now. So if you're doing the AC method, that's what you're going to do. If you're doing trial and error, that's what you're going to do. If you're doing the ninja method, that's what you're going to do. I don't know what your teacher done taught you. If I ain't your teacher, then I know what I taught you, but I ain't your teacher, right? So whatever you're doing, that's what you're going to do. Here we are doing trial and error. Start with what you know. And we know for sure about that first term, 3x squared. We know we're going to have a 3x and an x somewhere. I don't care where you put it. We know we're going to have it. What matters is where we put the factors for that 5. And we have a 1 and a 5. So if you don't know, just plug them in, and don't forget to check it with your FOIL. FOIL is your fallback, and you got to believe it. So I'm going to do my outer and inner check so I can see if my middle term is going to come. Do I have any signs in there yet? No. I want to make sure the number's going to come out right. So my outer check gives me 15x. Do we agree? The inner gives me 1x. And if I subtract that, I can get a 14x. Now, can I get a positive 14x? I can if I make what positive? Okay, the 5 positive, the 1 negative. So here we are, plus 15, a negative 1. Yep, it worked. So I checked it. My factors are 3x minus 1, x plus 5. Doesn't matter which one you have written first or second, as long as both of them are there. If this is a multiple choice selection and they want you to simply tell them one of the factors, make sure you pay attention to which one you're circling. Here we are with number 3. It says evaluate for x equals negative 1, and they gave you this function. Looking at the multiple choice selection, can you tell me which one of these answers can't be our answer? D. Again, D. That word undefined means what again? We have a 0 in our denominator. Do we even have a denominator in the problem? Can't be my answer. Do you see that? They give you these words in there, don't even apply. But if you don't know what it means, you're going to circle it. Don't do it. Don't let them lead you down the wrong road. Okay? Don't apply here. So now we need to find out what our answer is. If you are putting the whole entire thing into your calculator, you have to use the parentheses functions. Okay, so scientific calculator, graphic calculator, you have parentheses in there. If you're doing it piece at a time, still use the parentheses. Okay, you don't really need them. They're going to give you a number, and it is going to be negative. Why? Because they want you to mess up the signs. But if you put it in your calculator, it should look just like this. It should look just like that. Pushing your buttons, making sure that you put those parentheses in there, and when you push enter, the right answer is going to come out every time. But now if you don't put them parentheses in there, it's going to throw that negative sign off, and it's going to make your answer incorrect without using the calculator. We have a negative 1 raised to the 3rd power. Negative 1 raised to the 3rd power gives me what? A negative 1, right? And negative 1 times a negative 5, isn't that a positive 5? Then we have negative 1 squared gives me what? Is it negative? Positive. Positive 1 times 7. Make sure you're paying attention. Even exponent, positive, right? Odd exponent, still negative. Okay? So here we are. Negative times the negatives, right? Plus the 3. Tell me at this particular point which answer can't be my answer. Negative 21. We don't have no negatives, do we? Okay, can't be my answer. Now, which one is it? Is it going to be a 3? No. You don't even have to finish it, but you know logically it can't be between a 3 and a 27. It's got to be. So making sure we remember what we know. Number 4, it says factor. And they give us 16a to the 3rd minus 25a. What's the first thing we need to do when we're factoring this? Okay, we're going to take out the a. So if we know for sure that we could factor out an a, which one of these answers is not my answer? Prime, right? Yes. Prime means you can't take nothing out, right? As soon as you identify that you could take out an a, prime is gone. Now I know I have an a in my answer. So I take out the a. And I'm going to be left with 16a squared. Do we agree? Minus, can I go any further? Yeah. Look at the answers. Here they have that answer as B. Do you see that? But they're looking for you to stop right there. We have to look at our answer and say, hey, you know what? This fits the criteria right here. I can go a little further. That's a difference of 2 squares. That's going to break up into 4a and 4a. 25 breaks up into 5 and 5. 1 positive, 1 negative. Everybody see it? A is my answer. Think about it. Always ask that general question. Is there anything that you could factor out? A lot of times in your problems on the test, really that's about it. You can factor out one thing. It might be a letter, it just might be a number, or it might be a letter and a number. Okay? And then you might not be able to go any further than that. But that's still the initial start, because if you can factor out one thing, then you might be able to go a little further. Say in the free response section, problem number 12. Number 5, we're subtracting. When you're adding, subtracting, solving, you need a common denominator. Okay? When they ask you for a common denominator, you need a common denominator. What's our common denominator here? Well, right now, what is b squared minus 16, right? Remember, we're looking at it and we're like, wait, b squared minus 16, you know what? I could factor that. Not yet, but you will. Our goal is to get what they're asking us to do out of the way. So if they're asking us to subtract, we focus on the subtract. If they're asking us to add, we focus on the adding. So we've identified our common denominator. We see that both of them have the common denominator. I'm going to keep it for right now, so I can get the subtraction out of the way. So now that they have the same common denominator, now I can subtract because I don't have to replace anything, right? Okay, so now I can subtract across. But what do we have to remember about subtraction? You got to take and change every single thing that follows behind that subtraction. So we're going to write everything that's here, 7b minus 9. Whatever's there, you're going to write it. Here's the subtraction. We're subtracting. It's just like distributing this -1 all the way to everything behind it. So we get negative 6b. Do we agree? Then what? Plus 5. If you don't do that and get that last piece, I promise you they're going to have the answer there. Okay? Make sure you distribute that negative all the way through everything that follows behind it. Is everybody all right with the subtraction? Let's clean it up now. We got to combine like terms. 7b minus 6b gives me what? B. And then negative 9 plus 5 gives me a negative. Here we are with the factoring part now. So now we're at the simplification part. So if you could factor something, this is the time to do it. We have b squared minus 16. We know breaks up into what happens next? 1 over b plus 4. Make sure that you don't forget that you have to have this 1 up here. All right? So when things cancel and everything cancels out of your numerator and you're left with the denominator, you can't bring that denominator up. Okay? It still has to stay down there, and that 1's got to hold the place. So we have 1 over b plus 4. It says state the domain of, and here's a function. What does domain mean? To find the domain, she says we got to set the denominator equal to 0. Do we agree with that? What do we do with the numerator? Don't worry about it. Don't do nothing with it. You can't have a denominator unless you have a numerator, right? So if they're going to give you a fraction, they got to have something on the top. I don't care how good it looks. I don't care if it looks like you could cross something out. Don't touch it. Here we are, looking for the domain. A domain means our x value, for one. But more importantly, so domain means not only the x values, but it means which x value is going to make our denominator undefined. So remember we saw that undefined term in those other problems? Here's where it applies now. We want to find that number or numbers that will make our expression undefined. If you don't remember that you need to set the denominator equal to 0 and solve it, how else can we figure it out? Just take and plug in the numbers, right? Into the denominator. And whichever one give you 0, got to be your answer. Make sense? Okay? As long as you know what you're looking for, sometimes there's ways to work around it. But take our denominator, set it equal to 0, and solve it. You want to go ahead and add the 5x over? And then what does x equal? So our answer, D. Look at the numbers they gave us. They gave us a positive 5, a negative 6, and a positive 6. You only have so many numbers to plug in if you're going to go that route, right? So when I look at it, I'm looking at checking out the 5 first, right? Because I have a 5 here, and I have a 5 here. So if I plug that 5 in, and it doesn't give me a 0, I know automatically that A and C can't be my answer. Do you see that? Yeah? So if I plug a 5 in, 5 times 5 is 25. 30 minus 25 is not 0. So A, C, out. Then I have a positive 6 and a negative 6 to choose from. If I just watch my signs, I can plug in the negative 6. I know that negative 6 times 5 is a positive 30. 30 plus 30 is 60, right? Can't give me a 0. It has to be D. Does that make sense? Here's 7 through 13. We have multiple choice selections for number 7 and number 13. Number 7 says factor x squared plus 81. What is wrong with this problem? The plus sign. Is it a difference of 2 squares? No. Always check. Again, the first thing you should ask is, do they have anything in common that we could take out, right? That was our first question. They did not have anything in common. Then your second question is the first term perfect? Is the last term perfect? Subtraction in the middle? So one no is all you need. Right there, you can't do anything with it. Your answer is prime. If all else fails, and you just don't know, work backwards from the answers. If we FOIL this, right, by looking at it, we should see that we should get x squared, right? And then we should get a negative 81. Got it? But we don't have that, so we know that A wouldn't be our answer. Do you see that? Then we have 2 of the same thing here, x minus 9 all squared. Write them right next to each other. FOIL them, we'll see that we don't get this thing, okay? Again, FOIL this, you won't get this thing. That makes sense? You won't get it. You'll get a middle term, okay? You'll get 18x in the middle. Not there. So if all else fails, FOIL your answers. It takes a little longer, but if you know how to FOIL well, you could do it quickly. And then you can check to see if your answer is going to come out. If they're going to get the original thing, then you'll know that, hey, this is my answer. If you'd ever get it, it must be prime. But remember, you can only factor a difference of 2 squares, not the sum. Number 8, it says solve. And we have 6x squared equals 30x. What are we going to do first? Subtract 30x. Remember, you cannot factor over an equal sign. So you need to go ahead and set it all equal to 0. Now it's different if we had a fractional thing in there and we was asked to solve with fractions. We wouldn't have to set that equal to 0, right? Then we know what we need to do with that. And we're going to do an example later on. But here we're going to set it equal to 0 and solve it. What do they have in common? If you didn't see the 6, don't beat yourself up. You have to see the x, okay? When they add the equal 0 to your problem, it gives you some flexibility. Factoring is our friend in the respects that if we could factor everything out at the jump, whatever's left has got to be our answer, right? It's already simplified. But if you don't see all the numbers, like some of you might have said, you know what, they got a 2x in common. You could take that out. All I see is an x. What you're going to do, you're going to simplify your fraction at the end. Factoring helps us simplify from the jump. So if you could take everything out right from the start, do it. So 6x, that leaves us an x. Do we agree? Minus. So setting each one of these equal to 0, we should see 2 answers come out. So 6x equals 0 and x minus 5 equals 0. What does this x equal? 0. And this x over here equals 5. If this is in the free response section, then you got to show all your steps. You got to show all this right here. So you get all your points. You can say x equals 0, 5, just make sure you box it in. Okay, she says, how did I move the 30x over? I subtracted it over. So you see here in the original problem, it was a positive 30x. So in order to move it over, I have to subtract it over. So always think opposite. Number 9, it says add these two things together. When again, you're adding, subtracting, or solving, you need a common denominator. In order to find the common denominator, what do we need to do? Okay, take the 4 out of the denominator there. So we got to factor our denominators. Whatever you got, see if you can factor it. And if you can, do it. We can't do anything with this. It's just x minus y. But here, they have a 4 in common. I need to take it out. And that leaves me with 4 times x minus y. My common denominator is what? 4 and x minus y. Okay? Remembering our process to finding our common denominator. After we finish factoring our denominators, write all the factors for your first denominator no matter how many times it repeats. So we have an x minus y. I'm going to write it. Then I'm going to look at my second denominator and see what's missing. I already have an x minus y, but I don't have the 4. Is everybody all right? So my common denominator, 4 times x minus y. Now I need to replace what's missing. So if something doesn't have all of my denominator, I need to replace it. What's missing from this first fraction? 4. So in the form of 1, I need to replace that 4. We don't have anything missing from our second fraction, so we're good. Now that I've replaced what's missing, now I can do the additional subtraction, whatever they ask me to do. So we're adding here. So here we have 4 times x. That gives me 4x plus, and then I didn't have to do anything with this but rewrite it, 3x minus 5. Here I am at the cleanup now. I got to combine like terms on the top. 4x plus 3x minus the 5. All over my common hoo-ha thing down here. Remember, it follows you to the very end, right? Can we cancel anything? No? We can't cancel these x's right here? Nope. Joined. Can't break it up. Our answer, just that thing right there. Her question was, is it okay if you don't factor at the jump, but you factor at the end? Your denominators. You usually need to factor your denominators, so that's how you know what your common one is, so you'll know what's missing. Okay? Because this is really friendly right here. But on the test, they might give you some trinomials. You know, you're going to need to factor that in order to see what your common denominator is. So factoring from the jump so you can find that common denominator is probably your best bet. Number 10, it says factor, and we have a to the 4th minus 81. Do they have anything in common between all two parts? No? Is the first term perfect? Yeah. Last term perfect? Subtraction in the middle? I can do it. I know it's going to be something look like that, right? What does a to the 4th break up into? A squared, a squared. And 81 breaks up into? And then one is, and the other? That's what the definition says. Am I finished? Looking at what you have, you should be able to tell if you can go one more time. And sometimes you might be able to go another time. Can't do nothing with this right here. It's a plus. Do you see that? We know we cannot factor the sum of two squares. So what we can do, rewrite it. It's in our answer forever. But this right here, we can break this up one more time and we get what? And that's as far as I can take it. You can factor something one time, look at your answer, see if you can go one more time. Number 11, write in lowest terms. Lowest terms, simplify, reduce, all of that means the same thing, right? We still got to factor. Whatever you got, see if you can factor it. All right? Ask your questions. They didn't have anything in common, so if it can't do anything with it, rewrite it. And a lot of problems on the test are going to have components in it where you're just rewriting it. Okay? Just make sure you rewrite it correctly. Do not change those signs. Just arbitrarily change signs, okay? And then we factored. Our denominator didn't have anything in common, but it's a difference of two squares. What can we do next? 1 over y plus 7. Don't forget the 1. That's going to come up a couple of times on there. Number 12, we're factoring We have x squared plus 2xy plus y squared. Do they have anything in common between all three parts? No. Is the first term perfect? Is the last term perfect? Can the middle be broken up into two equal parts that can be combined? Yes. 1x squared xy and 1xy equals 2xy, right? So it can be broken up. This is a perfect square trinomial. You see that? It answered yes to all of our questions. The first term was perfect. The last term's perfect. This can be broken up into two parts that you can add together. It's perfect. That means what? She says x plus y, and then what? X plus y? Okay. So we know for sure, because of the definition, that it's going to give me two of the same exact binomials. So you're going to take your first term and break it up. X squared breaks up into x and x. Your last term breaks up into y and y. And we know our middle term tells us what the signs are going to be. So if the middle term is positive, both are positive. If it's negative, both are negative. So here we have a positive term, so both of them are going to be positive. Or we can rewrite this as what? X plus y all squared. So on the test, this may be a multiple choice selection, who knows? But if you don't see the two, right, written separately, they may have it written like this. So you'll know that you have two of the same thing. Make sense? Okay? But remember what we know. And again, if you don't know, you don't really see it, FOIL it. Okay? FOIL is our friend. Number 13, if they give you this function right here, they want us to find f of negative 6. What do they want us to do? Okay, we're going to plug in the negative 6 and see what we get. What did we get? Undefined. Did everybody get a 0 in the denominator? Yeah? So you should have gotten a negative 24 all over 0. Is everybody all right with that? Negative 24 all over 0. But you can't leave it like that, because do you see your answer there? What is this equal? Undefined. Now, if you have a really sophisticated calculator, it will actually say undefined when you put this in there. But if you have a regular calculator like I do, when you put that in your calculator, it's going to say error. Error means undefined. Make sure you don't get happy and circle B. That's not what that says. It's 0 only when you have a 0 in the numerator and a number in the denominator. Okay? That's when your answer is 0. But here, undefined, A is our answer. 14 through 19, you have multiple choice selections for 17 and 18. Number 14, it says solve. When do you need a common denominator? Adding, subtracting, solving. Okay? You need a common denominator. So what's our common denominator here? 2x plus 1 and x minus 3. Well, we couldn't factor them. But if we could, we would, right? But we didn't need to factor them. We have two different denominators. Write the first denominator, all the factors for it, and we got x minus 3. And then we looked and saw that we didn't have a 2x plus 1. This is my common denominator. What am I going to do with it now? We got to set it equal to 0 so we can find what? The domain. So first things first, find the common denominator. Then we got to set it equal to 0 so we can find the domain. You have to find the domain. What's the key word? Solve, right? And they give you a fraction with a letter in the denominator, domain. So our domain, x can be any number in the world. It just can't be what numbers? X can be any number in the world. It just can't be a positive 3 or a negative 1/2. So if this is a multiple choice selection and this is one of the choices, you got to cross it off because it can't equal these numbers. Now that we've found what it can't be, now we're going to solve it so we can see what we get. So if you're cross multiplying, this is where you do it. If you're multiplying through by your common denominator, here's our common denominator. You'll write it right next to each term. Either way, I'm just going to bring all my work down here. You'll get 6 times 2x plus 1, do we agree? equals 4 times x minus 3. So now, whether you cross multiplied or multiply through by the common denominator, your second step is going to be the same. Now we got to distribute and we get a 12, right? 12x plus equals, and then we need to combine like terms. So did you subtract the 4x over? So 12x minus 4x gave us a positive. That means we need to subtract the 6 over, and negative 12 minus 6 gives me a negative. So I'm going to bring it right up here. So my x equals a negative 18 over 8, which reduces to negative 9 over 4. You got to find the common denominator because you're going to use it to get rid of your fractions. So remember, adding and subtracting, keep the denominator. Solving, get rid of it. Number 15, we're factoring. Do they have anything in common between all 4 parts? Nope. We see that we have 4 terms with nothing in common. Grouping is the way we got to go. All right. Remember, there's 2 distinct ways to group. A lot of times you can group the first 2 together and the last 2 together. Some of us realize that we could do the second term and the last term, the first term and the third term together, and that's fine. Okay. Just watch your signs. I'm going to go with the first 2 and the last 2. So x to the third minus 8x squared. Group it together. Standard plus in the middle. Remember, signs go with the terms. Then we're going to factor out what they have in common. What do they have in common in the first one? Okay, x squared, and that leaves me with what? I need to see if I can get an x minus 8 over here. What am I factoring out? A negative 2. My leading term is negative. Something negative's got to come out. That's the key. So I'm going to bring the negative 2 out. That's going to change my sign out here. And that's going to leave me with x minus 8. Again, remember, those signs got to change inside the parentheses too. If all else fails, when you factor out that negative term, go ahead and do a little quick verbal check to make sure you factored it out and left the right sign. So negative 2 times x gave me a negative 2x. Negative 2 times a negative 8 gave me a positive 16. I'm good. All right, so now they have something in common that I could take out. What is it? Can I factor that anymore? Isn't this a difference of 2 squares right here? Is the first term perfect? Is the last term perfect? No. Okay? That's a 2. Can't break that up. 1 times 1 does not equal 2. And they're probably going to have an answer similar to that. If this is a multiple choice selection, make sure you watch it. Okay? You got to stop right here. You're done. Number 16 says simplify, and they gave us a fraction divided by a fraction. It doesn't matter what the fractions are. The fractions could be letters. It could be numbers. It could be pictures of some fruit. It doesn't matter. A fraction divided by a fraction, you're going to multiply by the reciprocal every single time. Keep, change, flip. That's what we got to do. We're going to keep that first fraction. Okay, that first fraction says z all over t squared, doesn't it? Change this division sign to multiplication. Take the reciprocal of the second expression, t all over z squared. Can we simplify? We can do it. Our exponential rule's right there for us to do it with. This t will go away with one of these. Do we agree? I'm going to put a little 1 right there so we'll know one of them there. What about these z's? The same thing, right? What's our answer? 1 over, don't forget the 1, zt or tz, whichever one. Both of them are correct. Keep it simple. You've seen this problem in the lesson. You've seen it in the homework. You've seen it in the review in your book. You've seen it in the review right here. Number 17, write in lowest terms. Here we are again. Got some multiple choice selections. Write in lowest terms. Can we simplify this thing? We got to take out a negative 1. Doesn't it look like it could cancel? It looks similar. If something looks similar, but the signs are different, that negative 1's got to come into play. All right? So we can take out a negative 1. It doesn't matter, top or bottom. It doesn't matter, just not both. Okay? But I'm going to do the top because the top looks weird to me. You have a 3 coming to a t to a 3. I like the t coming first. We like that. So So take the 1 out of the top, and that's going to change this top part around these signs, and that's going to make that a positive t minus a 3, which looks exactly like the bottom now. So remember, this is about the second time we've seen it so far, just in this review. So you're going to know something looks similar, look like it could cross out. You can't just make it cross out just because you want it to, okay? You got to do some mathematical something to make it work. That -1 is going to be that mathematical thing. Now that we've crossed it out, what are we left with? -1. Number 18, find the least common denominator. They just want you to find the common denominator. What do we have to do it? We got to factor. Factor in what out of this first denominator? And then we factor out what here? When we're finding the common denominator, what are we going to do with this 2 and this 5 here? Multiply them together. Remember, we're not adding, okay? We're not subtracting. We're multiplying. So if we know that we're multiplying these two things together, we know that C and D can't be our answer. Which one is our answer? B. What's wrong with A? They counted that x plus 6 twice. Do we do that? Nope. Watch those exponents. Here we are with number 19. Again, we're simplifying. Remember, we're looking at this thing. I do not want to see, oh, these 5s are here. I can cancel them. Don't you do it. That is illegal, okay? What we got to do? Factor. We got some trinomials. We got to do what we got to do. Do they have anything in common between all 3 parts that we could factor out of the top? No. Is the first term perfect? Nope. So we need to go old school. Old school just means regular. Just regular. That's what we're doing, regular. Start with what you know. And we know for sure about that 3x squared. We know we're going to have a 3x and an x somewhere. Start with what you know. Then we have that 5 on the end. We only have 1 and 5. Where's the 5 going to go? In the first one? Okay, we have a 5 and a 1. I'm going to do my inner and outer check to make sure my middle term is going to come in. So here we have that. Gives me a 3x. The inner gives me a, and if I add it together, I can get the 8x that I need. Do you see I'm on the right track? So I need a -8. That means I need to add these two things together to get a -8. Do we agree? That means both of these need to be negative. And that's going to give me my positive 5 on the end. -5 times -1, positive 5. I'm good. She did the AC method. She multiplied the first term and the last term together. And so 3x squared times 5 gave you a 15x squared, right? So now you have to look at the factors of that 15. Right? So you have 1 times 15 and 3 times 5 and all that good stuff, right? And then you're going to see which one you're going to use, whether it makes your which one is going to be positive, which one's going to be negative. And then she's changing it into grouping. So if you're doing that method, that's fine. You just got to make sure that your signs in the middle is going to give you that middle term, right? With your signs, not just the numbers, but the signs too. Okay? And then factor it as factor by grouping. You still should get the same 2 terms. So check your third step after you finish looking at your factors and you plugged it into your grouping part. When you start factoring out what they have in common, that's where something happened there. Okay, that's usually your third step. Okay, all right. So now we've got the top going. We need to get the bottom going. Do they have anything in common between all 3 parts? Is it perfect? No, the first term is, but that last term isn't, right? Start with what we know. And we know for sure about the 5. I know I'm going to have a 5 and a 1. I can't go wrong with it. Now I need to make sure my lead off is going to happen. I have a 4x squared, so I have 1 times 4 and 2 times 2. Do we agree? Okay, which one are we using? We're going to use the 4. So I'm going to do a 4x and a 1x. Okay, let me try to see if that's going to give me what I need. My outer term gives me a 4x. My inner gives me a 5x. And if I add them, I could get a 9x. Do we see that? I'm on the right track. Now, can I get a -9? That means both of them would have to be negative. And it works out, gives me a positive 5 on the end. I'm good. Always check your trinomial factory. Never trust it, or your AC methods factory. Same deal, okay? Always check it. So now that we've factored, we've checked, Now, can we get rid of something? We could get rid of this thing right here. And can we get rid of these 5s right here? Nope, can't do it. So we get 3x minus 5 all over 4x minus 5. And that is our result. Always, always check. How much factoring did we do? Factoring, 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 right? Had to factor out the negative. Factoring, factoring. You see that? A lot of factoring. We got multiple choice for numbers 20 and 24. All right, so number 20. To solve it, you got to set it equal to 0. And I think I saw that pretty good, right? Just making sure we watch our signs. So we should have x squared minus x minus 6 equals 0. And then again, making sure we check what we have. So if it's a multiple choice selection, then you can take and plug your answers in and see if it gives you 0. Do you know that? You do that. But if it's not a multiple choice selection, then you got to factor it all out, right? Okay, doesn't have anything in common between all 3 parts, and we know it's not perfect. So we use x and x, and the factors for 6 we used 2 and 3, and the 3 is going to be negative, the 2 is positive. Here is my verbal check. Because my leading term is a 1, I can do a verbal check and know that if I multiply these 2 numbers together, I'll get my negative 6 back. But when I subtract the 2 numbers, I'll get my negative 1 in the middle. Is everybody all right? So now to solve for x, I need to set these equal to 0. So I get x equals a negative 2 and a positive 3. B is my answer. This term right here, we know what that means, right? What does it mean? Can't be factored. They asked us to solve. That doesn't apply. Okay? If they had asked us to factor completely, that's it, just factor completely. And then we couldn't do anything to it, prime might be an option, okay? But when they ask you to solve, usually there's something that you can do. You can factor and you can get an answer, okay? All right. Number 21, we're dividing these 2 fractions again. How do we say we divide 2 fractions? Keep, change, flip. So I'm going to factor everything I can. We don't need a common denominator, but I'm going to factor everything I can. And this top part right here, this trinomial, we factored it. I think I saw everybody did pretty well here. Our factors for 20 are, so negative 5 and a positive. So when I multiply these 2 numbers together, I get my negative 20 back. When I subtract the 2 numbers, I get my negative 1 in the middle. Make sure you check it before you move on. Then down here, what can I factor out? A 2, and then what else? Y squared. And then that leaves me y minus, here's my change, here's my flip. All right, so the bottom, this top part comes to the bottom, and I can factor out what? That leaves me y minus 5. And then this right here, I got to do 2 things to it. Watch it now. What's the first thing? Okay, we're going to factor out a y, and then that leaves me 4y squared minus 9. Is everybody all right? Then I can factor this thing right here, can't I? Make sure you keep the y there. And this breaks down into 2y and 2y. What else? Positive 3 and a negative 3. So now this goes away right there. You've factored, you've checked, you've flipped, all that good stuff. Now let's see what we can get rid of. What can we get rid of? Okay. Is that it? We factored out a y here. We factored out 2 of them down here. We can cancel that. Okay, and leave 1 right there. Anything else? Let's bring it all together now. Remember, your answer is what it is. You don't know what it is until you get there. Did I forget the y minus 3? Oh, I sure did. Thank you. See, that y minus 3 is still there. So remember, your answer can be bulky. Everything could cancel and leave you a cute little number. It could just leave you one little letter. You don't know, okay? But make sure when you're factoring, you're checking, okay? And then you're looking to see if you can get rid of some stuff, okay? What they want you to forget is when you factor out these letters. See that? Watch that. That's going to be really important. 22, we're subtracting. What's the common denominator? Okay, x plus 2, x minus 2. Do we see it? We got to factor. This factors into x plus 2, x minus 2. What's missing from this second fraction over here? There it is, we replaced it. We're subtracting, watch it. When we subtract, what do we get on the top? So 7x. And then what? Negative 3x, and then negative 6. Do you see that? You got to take this negative 3 and we got to distribute it. We got to touch everything behind it. They're really going to try to hem you up with that subtraction. Make sure you hit everything. All right? So now you have 7x minus 3x gives us a positive. Positive. Negative 2 minus 6 is a negative. All over our common denominator. Is there anything else we can do with it? A factor out of 4. You got to look at it. If you could take it out, you got to take it out. Factor out the 4, and what are we going to be left with? Is something going to happen? The x minus 2's cancel. And our final result, number 23. If an object is propelled up from the ground with the initial velocity of 64 feet per second, its height h in feet, t seconds later is given by this function right here. After how many seconds does the object hit the ground? What are we going to do? How did we know? What was the key word to let us know we was going to set it equal to 0? Ground. Ground level. Yo. Do we agree that something that gets hit, right? And it goes up and has to come back down, right? Okay. When it asks you when does the object hit the ground, remember that's ground level. So you're here and this thing is on the ground, right? It's propelled up and it has to come back down. So this is 0 level. So you always set whatever they give you equal to 0, and you're going to find out what? What do we know? We know that t equals 0 right here, right? The initial time. We need to know when whatever we threw up in the air, what that's going to be. So here we have negative 16t squared plus 64t equal to 0. And then we're going to factor it. What are we factoring? Okay, can 16 go into 64? How many times? Or 4 times. And what else do we know we have to take out? The t. My leading term is negative. Can I take out a negative something? If I wanted to, right? I could do that. So if you just took out the t, that's fine. If you took out a 16t, great. If you took out a negative 16t, you on the ball, okay? But remember, it's going to work out in the end because we're solving. So I'm going to go ahead and take out the negative 16t because I know I can do it. Making sure we're okay with our signs. When I factor it out, I should be left with a positive t. Do we agree? Then a minus what? 4. We already know what our first t is. We said it was t equals 0. Don't we agree that if we set this equal to 0, we're going to get t equals 0? what are we going to get next over here? So t equals 4 seconds. And that is my answer. So 4 seconds it takes for that thing to hit the ground. All this write-up right here is just to paint a picture for you of what's happening with this object. This 64 feet per second stuff has nothing to do with us solving the problem. That is just extra information. Is everybody all right? Please don't try to plug it into your problem. Don't try to set your problem equal to that stuff. It don't have nothing to do with you. And the last one, 24, says solve for x. And we have, what is that? Nx equals c minus mx. What are we going to do first? Add the mx? Okay. Before we go any further, can we look at the multiple choice selections and tell me which one can't be my answer? What's wrong with C? If you're solving for x and what you have, your answer has an x on both sides of the equal sign, that's not your answer because you didn't solve for it. So that can't be our answer. Okay, so we ruled out at least one thing there. Now we know in order to solve, we got to isolate all of our x terms. So this one's already over here, so nx. So add the mx to it, right? Okay, and now what? Okay, well, we're not going to divide by it, but we're going to take something out. What are we going to take out? The x, because that's what we're looking for, right? Okay, we're going to take out the x. And we're going to be left with n, do we agree? Plus, Okay, now what? Now can we divide? We're going to divide by this junk right here. I don't even care what that stuff is. I'm just going to divide by it. N plus m. All over n plus m, that goes away and leave me x equals c over n plus m. D is my answer. Practice. Work that stuff in your book, right? Okay? Good luck with your test. Thank you for coming.